Audio Jungle.
MQ clients are nothing but the end application who are connecting to MQ.
Okay.
Okay. This could be, for example, a Java program who is connecting to MQ to put a message or get a message, or it might be, for example, a C program or a VB application, a COBOL application, .NET program, anything it could be.
Mm-hmm.
End applications who are connecting to MQ to put a message or get a message, these are called MQ clients.
Okay.
Okay, so just the terminology, because multiple places or even in books we might be coming across these kind of terminology, so we should be aware of it. That's right.
Yeah.
And these MQ clients again will be exposed to some APIs. Okay, some standard interfaces are available which will be exposed to these particular clients. These are called MQI calls.
MQI. Okay.
MQI means MQ interface.
Okay.
Okay, so generally the C programming language or Java programming language, they will implement these MQI interfaces so that they can communicate to MQ product.
Mm-hmm.
So one of the interview question, how can any programming language can connect to my MQ product? Okay, so then we can say we have actually some standard uh, interfaces or APIs available, okay, which will be exposed to the clients, means the client applications. It could be C, Java, etc., .NET, and they will be actually implementing the interfaces provided by MQ,
Okay.
which are called MQI calls, or it might be JMS. JMS is a very standard interface actually for
Mm-hmm.
message oriented communication, and this JMS is not only supported by alone message broker, this WebSphere MQ product, but almost all standard MQ products available in market.
Okay.
Okay, it could be like WebSphere MQ, it might be WebLogic MQ, or even Sonic MQ, or Rabbit MQ, Active MQ. Any MQ product we take, actually it supports internally JMS. So
Okay.
all these are called MQI clients. Okay, and generally these MQI clients will be bidirectional. So bidirectional in the sense the same single channel can be used to send the data as well as receive the data. Both.
Mm.
Okay. Yeah. Can you just tell me about MQ architecture according to what you know?
MQ architecture.
Yeah. Any idea
Which,
about anything you remember?
yeah, it's like the client system will send a message to MQ, which has different queues in it, like local queue, alias queue, model queue. So when we send any message to the MQ, MQI listens to the message and it sends to MQ and responds back using MQI back. I think that's the way it is. I don't remember exactly.
Okay, okay. So generally when we install WebSphere MQ software, okay, it will be just an environment. A message-oriented server will be available, but we can create whenever we require something called as queue managers.
Yeah. Yes.
Okay. So can we have more than one queue manager inside a WebSphere MQ product?
Yes.
Yes. So we can create multiple queue managers inside an MQ server actually. And inside this queue managers, we will be having multiple queues.
Yes.
Okay. So
Is there a limit to how many queue managers we can create and how many queues can a queue manager has?
no, not actually that particular thing depends on the hardware. Okay, the hardware support. When we say evaluation version of MQ, yeah, yes, it will not allow you more than 8 to 10 queue managers.
Okay.
But the real limitation of number of queue managers and queues inside queue manager actually depends on the hardware capability. If I have a big support, means a big server with good support for hardware, then it might actually support many. The single MQ product can have multiple queue managers, and this single queue manager can have multiple queues, and even the queue managers interact with each other. Means one queue manager can communicate to another queue manager to send a message or receive the message, and during that communication they will use a channel, and that channel is called as, any idea?
I know they communicate with remote definition queue, and
Okay.
that's I
Is it
don't know.
possible to communicate between two queue managers without remote definition queue?
No, we have to have a transition queue.
Mm, no, no, but without remote queue definition, is it
No,
possible?
no.
Actually, answer is yes. It is possible even without remote queue definition. Okay,
Okay.
so remote queue definition will come later, but yes, the two queue managers to interact with each other, there is one channel which is required, which is called as message channel.
Okay.
Okay, so there are two types of channels generally which we have. One is called as MQI channel, and one more is called as message channel. MQI channel is always between application, means the MQ client and the MQ product.
Okay.
Okay, means like C program want to communicate with my queue to put a message. So in that case, they will make use of MQI channel. It might be Java program want to communicate with my queue to put or get a message. Then they will communicate through MQI channel.
Okay.
Okay, whereas message channels are always between two queue managers. So we can say MQI channel is between application and queue manager, whereas message channels are between the two queue managers.
Okay.
So yeah, so among the MQ product itself, if one queue manager want to send the data from its queue to another queue manager's queue, so in that case message channels are used. So these are the basic types of channels. And then MQI channel, one more property of MQI channel is it is unidirectional. Sorry, MQI channel is bidirectional.
Okay.
Okay, means if
Message
I
channel
have a single, sorry,
and message channel
is unidirectional.
okay.
Means if I have one message channel, it can either send the data or receive the data, but not both.
Okay.
Okay, so it is unidirectional. Message channel bidirectional and message channel unidirectional. And then again in message channel we have message multiple different types of message channels which we'll see later. Okay, so at upper level right now what to understand is first of all we will have MQ software installed. One MQ software can have multiple queue managers.
Hmm.
One queue manager can have multiple queue. If
Hmm.
a client application want to communicate to my queue manager, then these are the MQI clients or APIs which are exposed to client, which is
Hmm.
called MQI, AMQ, JMS, etc. Whereas if a queue manager want to communicate with other queue manager, then we make use of message channel.
Okay.
Okay, so MQI channel are generally bidirectionals, whereas message channels are unidirectional.
Hmm.
Okay.
Okay.
Yeah, so this is nothing but the upper level, nothing but the architecture of MQ we can say. Okay, now coming internally, like just we said that one MQ product can have multiple queue managers. Like in a company we can have multiple managers. Okay,
Mm-hmm.
and again when we say company with multiple manager again will have furthermore employees under them whom they will manage.
Mm-hmm.
Likewise, a queue manager can have multiple queues under it whom the queue manager will be managing.
Okay.
Okay. And again, like in organization, under manager will have multiple employees, but will all the employees will have same role?
No.
Okay. Means for example, a manager is there, under him there are 8 employees. Okay. Will
They
all 8 employees will have same similar role or different?
they can have different roles.
Like in a company, we can have a manager with multiple employees. Here we have queue managers with multiple queue. And as in a company, under a manager, all the employees will have different roles. Likewise, here also inside the queue managers, we'll have multiple queues which will be for different purpose. Means we'll have different roles. And we have now different types of queues available here. So the next topic like types of queues. And when we say types of queues, generally all these queues are divided into only 4 basic categories. Means generally we have only 4 types of queues, and
Okay.
these 4 types of queues are the first, uh, which might be the first queue,
Local queue.
right? Local queue. So the first one is local queue. And what is local queue is,
It takes the data, stores and pushes the data. It can keep it with the queue for some time. It can store basically.
correct. So it generally doesn't push at all, but yes, it is the only physical queue which can store the data.
Yeah.
So there are multiple different types of queues, but the local queue is the only one which can store the data, means it can hold the data. Whereas
Yeah.
the second type of queue, and we have again furthermore types of local queues which we'll discuss later, so
Okay.
which can hold the data but for different purpose. So we have like example transmission queue, initiation queue, dead letter queue, like was many different types of local queues are there.
Yeah.
So and the second type of queue is
Alias queue.
yeah, alias queue. Now what is alias queue meant for?
Alias queue is basically to point it to the local queue. It does not hold the data, but if it is basically used for security, and if there is some queue manager or any client which is sending the data, it will point to alias queue, and alias queue will in turn point to a local queue which can hold the data. So the
Right.
client would
So
know exactly where the message is going.
right. So alias queue is generally just like a interface exposed to the client, okay, or the outer environment, rather than
Yeah.
exposing the real local queue which is storing the data. Because there might be many threats which might be there, like if directly the real queue name is known, which is storing the data, the client might do. He might be a hacker, so he might connect to that queue to do some either deleting the queue itself or deleting some messages, etc.
Yeah.
So we never expose directly the local queue. Alias queue is just a pointer to a local queue.
Yeah. Okay.
Yeah, fine. So, and then the third one is,
Model queue.
right, model queue. Now, what is the purpose of model queue?
Model queue is it is basically, I think, the runtime kind of queue which will create a lot of queues during the runtime having the same properties, and as soon as the program is run, it will go away.
Okay, yeah, one is that. Another,
Mm, I know that only.
yeah, there are two purposes of model queue. One purpose is to create at runtime the model queue, the local queues, means it will make a dynamic thing possible, so that at runtime if there is a queue needed, like for example one queue is already filled, and at runtime I need to immediately create one more local queue and then make that available to the client. So in that case, we can make use of model queue to dynamically generate the local queue. Second purpose is if I have a requirement of creating multiple local queues of similar structure,
Yeah,
then
correct.
also we make use of model queue. Model queue is something like in programming language we have classes which
Mm,
define the structure and we create multiple objects based on that class. Likewise, we have model queue here in MQ. So
mm,
we can define the properties in a model queue,
mm.
and whenever we want, we can create multiple local queues based on the same model queue structure.
Yeah.
Okay, like for example, it might be like persistence property, or it might be the queue depth, etc. Multiple properties, whatever we want, we can set
Mm,
it to model queue and generate multiple local queues based on the same similar structure.
yeah.
And then the last one, which is called remote queue definition.
Mm.
So now, according to you, tell me what is remote queue definition?
Remote queue definition is if I want to point from one queue manager of one system and I want to point it to another queue manager of another system. So we use remote queue definition, which basically takes the message from one queue manager and it transmits to the other.
Okay, fine. So in simple terms, remote queue definition is just like an alias queue.
Okay.
Okay, but the difference is alias queue is to point to local queue of current queue manager, whereas remote queue definition is to point to the queue of another queue manager.
Yeah.
Okay, that's why I say remote queue definition. Remote queue definition in the sense the definition of remote queue. Remote queue means always other queue manager's queue.
Mm-hmm.
Okay, so alias queue, remote queue definition, both are doing the job of pointer kind of thing, but only thing is same. Alias queue pointing to current queue manager queue, remote queue definition pointing to remote queue manager's queue. Okay, but
Yeah.
the real stuff, what exactly RQD does, will be clear once we cover that intercommunication topic. Okay,
Okay.
actually speaking, RQD is never pointing to remote queues queue manager. What it does, we'll discuss when we come to intercommunication topic. As of now, just we can remember like, okay, alias queue for current queue manager, remote queue definition for remote queues queue manager.
Okay.
Okay, yeah. So all these are nothing but the types of queues which we have. Okay, but if you see, in all these cases, like alias queue pointing to local queue of current queue manager, remote queue definition pointing to local queue of another queue manager, model queue, which is nothing but to create multiple queue local queues of the same structure as well as dynamically. Means all these are nothing but either pointing to some local queue or might be helping to generate the local queue. But none of these are actually storing the message.
Hmm.
The only queue which can store the message is local queue.
Yeah.
Okay. So, and now when we say these many queues we have even the programming APIs which are available to connect to this particular queues to either put a message or get a message. And we
Okay.
say that these are like MQI calls. Okay. All these are called MQI calls. The APIs which will help you to actually connect to the MQ's queue to either put or get a message. And these MQI calls are categorized into two main categories. One is called major calls and one more is called minor calls.
Okay.
Okay. So major calls and minor calls. Now this is from programming point of view. Okay. Now one of the interview question, how any programming language can connect to Java program? Sorry, any programming language can connect to WebSphere MQ. The
Okay.
reason is because in WebSphere MQ we have a standard MQI calls which is exposed to all the application programming interfaces.
I'm
So
sorry,
all
can
the
you repeat that?
in WebSphere MQ they have a standard MQI APIs.
Okay.
Okay, MQI APIs which are actually exposed to different application programming languages like C, Java, etc. So all these MQI calls will be implemented by these programming languages.
Okay.
Okay, so like example, that example I'll give once we cover this particular major and minor calls. Now what all the major calls could be is, major calls are those calls without which we cannot do any work on queues at all. Okay,
Okay.
like if I want to put a message into queue, what is the first thing a client should do? Means the client here means program who is connecting to MQ. Okay,
Hmm.
so first the application should do is he should connect to the queue manager.
Yeah.
Okay, which is called MQ con, means MQ connection. So this is the call which will connect to the queue manager.
Hmm.
Okay, whereas after connecting, the next thing the application should do is it should open the queue. Okay, so like once the queue manager be connected, next step, open the queue on which they want to perform the operation.
Hmm.
Okay, and then after opening the queue, they will be performing the operation like MQ get, or it might be MQ put. Means either they want to get a message or they might want to put a message. Okay, so these are the two things they might be performing, and it might be performed any number of times, but once it is done, then last they will be closing the queue. Okay,
Hmm.
MQ close, and then finally, so once they have closed one queue, then again they can open other queue, again can put get messages, again can close the queue. Likewise they can do with all the queues, and once they are done with all the queues, they might actually disconnect from the queue manager. So that is MQIDSC, short of disconnect.
Okay.
Okay, so now these are the major calls. Then what are minor calls? Minor calls in the sense which are optional. For example, if I have done get put all those things and I want something like I felt that I have put a message which should not be delivered to the end user.
Okay.
Is there any way that application has put a message but he will decide later that okay, this should not be delivered to the other end user?
It can be done.
Yeah, any idea what is that called as?
No, I think I forgot.
Actually, for that, the application program will have something called as transaction management.
Okay.
Okay, like in database we have insert query, we do insert record in table, but
Hmm.
until we say commit, it will not be stored in table for other clients. Okay, if I say rollback, then none of the records will be there in the table. I might
Correct.
have done 10 insert query execution, but after that, if I say rollback, none of the 10 queries you will find there, means records you will find there.
Correct.
Likewise, here also actually in programming language of MQ, we have transaction management. So application program might have put 10 message, means send the 10 message to queue, but he can say rollback so that none of these 10 message will be available to end user, even though if we connected to the same queue where message is put. And if he says commit, then only it should be available to other end user.
Yeah.
So this is called transaction management. So if I want to enable a transaction management, by default there will be no transaction at all enabled in MQ. Means by default it is auto committed. As soon as a message is put, it is available for end user. If it is removed, it is permanently deleted from the queue.
Okay.
Okay. But if I want to enable the transaction from programming point of view, then there is a call called as MQ begin. This is a call to start the transaction.
Okay.
Okay. And once transaction is started, then after putting multiple messages or getting multiple messages, the client, if it feels that he don't want to proceed with that, means after 10 messages he feel no, I don't want to keep it in queue, I want to roll back, then he
Hmm.
will be calling MQ back. MQ BACK means rollback. Okay. Whereas if you want to commit, then he will be calling MQ CMIT means short of commit.
Hmm.
Okay. So likewise, he can do the rollbacking or committing kind of things once transaction is started. Whereas again, if for example before doing the normal operation put, he want to check either the queue is full or not.
Okay.
Okay. Similarly, before getting the message from a queue, he want to check out either the queue is empty or not. Means he want to do some operation like these are called inquiry kind of thing. So
Hmm.
inquiring either queue is full or not, or it is empty or not. Similarly, it might be inquiring about how much big message I can put before putting a message, checking the maximum size of a message allowed in a queue.
Hmm.
So these kind of inquiries are called MQINQ. MQINQ. Okay, means inquiry. In Java, nothing but these are getter methods. Get message length, get queue depth. Likewise, we have message methods available. These are just to know the details about the MQ product from the client program.
Hmm.
That is called MQINQ. Whereas if rather than knowing, if I want to change the values, then we have MQ set. This is nothing but to change the value inside the, means might be changing some properties. If the queue depth is only 500 right now, I want to increase it to 1000, then I can call MQ set. These are called setter methods. But to do this, the programmer should have administration privileges.
Hmm.
Okay. So these are the calls. Now these are the standard calls which are defined by MQ product. Okay. But these calls are implemented in different languages. Okay. For example, if I take Java, in Java, this statement MQCon is nothing but written like this. Here, MQ open is like MQQ. This is a class available, and then the object name equal to new MQQ. Which queue matches queue you want to open and what is the queue name? Okay. So this is how it is written.
So at a time, I can open multiple local queues.
Yes, we can. And then similarly for MQ get and MQ put. These are the statements in Java. And then finally queue dot close to close the queue. And then disconnecting from queue manager. QM dot disconnect, which is QM dot close. Yeah. So likewise the statements would be there. Okay.
Okay.
So but these are the MQI calls. See, this MQCon is actually mapped to this statement in Java. So as a Java developer, when he is writing, he will write actually this code which is available here.
Hmm.
Okay. But if it is a C programmer, in C program, MQCon is a function available. And here in function, we will be passing the argument,
Okay.
queue manager name. Yeah. So see, this is what statement I have written over here is MQ.
Hmm.
calls which are in C language.
Yeah.
Okay. In C language, we actually write like this. Means we have the appropriate calls mapped to C functions.
Hmm.
But the same statement of major calls in C language and in Java language.
Hmm. 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 Yeah.
Okay, so this is how actually it is done for the whole code.
Okay.
Okay, so all the Java means all the languages are mapped to the common calls called as MQI calls, which are major and minor calls. And for every these calls, they are being implemented in different language.
Hmm.
So the programmer doesn't has to remember these major minor MQI calls. He will just write in his own language whatever he is comfortable with. But all these language APIs are actually mapped to some common MQI calls, which will be internally executed.
Okay.
Okay. So this is just to make vendor independent programming. Means any programming language can connect with website MQ product without any problem.
Hmm. Hmm. Hmm.
Okay. So this is the main idea behind how any programming language can connect to the website MQ product.
Okay. I have a question.
Hmm?
Uh, like as we discussed this local queue that the client will come, open the queue and put the message and then close the queue and then disconnect. So
Hmm?
I think there was one question that if you open and close the local queue multiple times, like a number of times, it gets corrupted.
Yeah, right.
Why is that so?
Yeah, that is why because it is not like a single client doing that. Because when we say a local queue, there might not be a single client who is connecting and opening and closing it.
Hmm.
It will be like new number of clients. It might be like 10, 100, thousands of clients who are connecting to a queue to
Mhm.
open and close it. So during that session, what happens is multiple clients will be trying to open the queue and at the same time multiple clients will be trying to close the queue. Okay, you can see there's a queue will have open input count, output count, all those things will be there. So
Mhm.
multiple clients simultaneously assume that one client is trying to close and other client is trying to open at the same time. So the
Okay.
software which is implemented for the queue to manage, it will get corrupted. It will be like multi-threaded programming language.
Okay.
So, so such kind of things will actually corrupt the queue. For that reason, it should be avoided. That is the reason why we generally don't give local queue at all to the client directly.
So we give the alias queue name that will point to the queue.
Yes. So it is better always to give the alias queue to the client, which will point to the local queue.
So this problem never happens with the alias queue because it is pointing, is it?
Yes. Yes. Alias queue is just for close and alias queue. There is no use of it because alias queue generally doesn't put anything at all.
Okay.
Okay. So it will be more safer to expose or give the alias queue to the client rather than the local queues.
So when I put a message in the alias queue, will alias queue go and open? So basically the clients come and open alias queue, put the message in the alias queue, close it.
Yeah.
Okay.
Okay. That is actually what clients feel that they are opening an alias queue, putting a message and closing it. Okay.
Hmm.
But without closing, there is no use because miss no problem because alias queue is just a pointer. It is actually not getting closed and opened.
Okay. Okay.
Okay, so alias queue will take care of internally how in well manner the local queue should be opened or closed, or even if you don't close, after how much time to wait and automatically close it, everything the local queue will automatically take care of.
Okay. Okay.
Yeah, and more actually more right thing to say is it is not taken care by alias queue, it will be taken care by the queue manager to
Okay.
decide that if the queue is not getting closed, after how much time the queue should be automatically closed to be at safer side.
Okay.